All right, this is our last example for this section. This time we're going to mix together two acids, HCl and HF. And the first problem that students are going to have is that they're going to look for a Ka value for HCl and wonder what to do when they don't have it. So just as a reminder, HCl is a strong acid and we do not have Ka values for strong acids. Also, you don't set up iceboxes for strong acids because we know that they dissociate 100%. What we're trying to figure out is if the HF dissociates enough to add enough H plus to the solution to change the pH of the hydrochloric acid solution. So the first thing we always want to do is to list out what we have. And we're actually going to break apart the strong acid. So if something is strong, or if it's a soluble salt, you are going to separate it as the major species because they're going to dissociate 100%. We always have water, and we also have this weak acid that we're going to keep together because most of it stays together. So these two are from the HCl that does complete dissociation. And because of that complete dissociation, the H plus concentration is the same as the original concentration because you have 1 mole of H plus for every 1 mole of HCl, and so the concentration will be the same. What we're trying to figure out is what this HF is going to contribute. For weak acids, you have to set up an icebox to see how much they break apart. So we are going to start with 2 molar of the HF. However, be careful here. You do not have 0 molar for hydrogen, the H plus, because you already have some from the HCl. So that 1 molar HCl has broken apart completely, so you actually have 1 molar of the H plus there. And then 0 for the F. We're going to shift it towards the 0. And now we can plug all that in for K. So products on the top divided by the reactants. We're going to go ahead and make this assumption. And then we can solve for x. So x equals 1.4 times 10 to the negative third. You should always check the assumption just to make sure. So we're going to take that x value, put it over the original concentration of the acid, times 100. And that gives us a very small percentage, so the assumption is good. On the AP exam, you should actually write that. The assumption is good. You shouldn't just put a check mark. So now we have the x value, and we can now plug it in for the concentration of H plus at equilibrium. So at equilibrium in our icebox, we had that H plus equals 1 plus x, which equals 1.001 if we don't round it, but we do have to do significant figures, and we were given 2 significant figures in the question, so when you round that, these 2 drop off. So notice that the concentration of H plus was not actually changed very much by the HF. And so now we can just take the pH is the negative log of that. And that is it for this question. So let's just take a look at this. You notice this is in the notes, section 14.4 and 14.5. The first thing you want to do is to look at the components. Again, make sure that if it's strong, you're going to break it apart. If it's weak, you're going to keep it together. And I cannot stress that enough, that you have to consider what you're starting with, because that'll help you figure out how to solve the problem. Keep in mind that at high concentrations of strong acid, the water is insignificant. The amount of water that breaks apart is not significant enough to actually calculate that into the icebox. For strong acids, we make the assumption that the acid completely breaks apart. And then this is kind of all the steps that I just went through. So this is just kind of a guideline as you're solving these problems to help you figure out what to do. And just as a little hint, this little thing, I know you probably can't read it, got water smear on it, but you do have to consider if the H plus contributed by the acid is less than water. So keep in mind that water contributes, this concentration is the concentration of H plus given by water. So if water is more significant than the acid, then you want to focus on the water. And that's a hint because there's some problems in your progress check for today where water is going to actually be more significant than the acid. So just be careful with that.